if you want to unmute yourself, Roger,
Yep.
that would be great. Thank you. Yeah, Roger's a great friend to the branch, turns up and talks to us in his inimitable style on a regular basis, and for that we're eternally grateful. Thank you so much. Roger's got an interesting bag of stuff he wants to talk to us about. I know he's busy. He wants to be away before 12 if possible, and he said he'll give his talk and he wants to answer questions. Should we do questions at the end, Roger? Should we ask people to put questions in the chat and we'll pick them up afterwards?
Yeah, whatever's easiest, really.
Whatever's easy.
Chat or just ask directly, really.
Okay, jolly good. I'll put you on spotlight. We'll let you carry on if we may. Thank you.
Yeah. Well, thank you very much. Yes, I always seem to be very busy. I'm actually going on holiday, I booked to go camping in Yorkshire next week in December, and it's all worked out rather well. The only problem is it makes stay a bit busier than I anticipated, but it's lovely to see everybody on such a beautiful day. And I fully empathise with everybody's predicament for the last few months, which I know for many of you, based on my clinics, it's been very hard for people, generally speaking. First lockdown was quite entertaining and a bit of a break. Second lockdown was a bit of a pain. Third lockdown, seriously, was not much fun with the miserable weather. So I empathise with you, and I think your conversation was before about when you come back together in person, and that's obviously something we spend a lot of time here thinking about in terms of our clinics and our research activities, which now thankfully are opening up. So I thought what I would do today is just talk a little bit about some ideas, which you've probably heard me bang on about before in Parkinson's. I was going to talk a little bit about how people are thinking about subtypes of disease, stratification. And then if you stratify people, what does that actually mean in terms of how we then take therapies forward? Where are therapies? And then I was going to sort of end up talking a bit about cell and gene therapies and the sort of activities we're doing here, so people are aware what's happening locally. I would also advertise for the World Parkinson's Coalition virtual meeting, which is coming up next month. If you don't know about it, the WPC meeting, it's very good. I mean, I am biased because I'm heavily involved with it, and I've had to do lots of recordings of opening and closing remarks, but I watched yesterday all the talks from the second day, which are fantastic, from very scientific talks to incredibly practical talks. So I would recommend people do that. You can watch it anytime you like. You don't have to do it when it's actually released, but there's question and answers and interactive sessions. So that's the adverts over. So I'm going to sort of take us back to when I first came back to Cambridge in the late part of the last century, which makes me feel very old, to try and tackle a question around how we could better take therapies into patients with Parkinson's disease. And the sort of prevalent view at that time was that Parkinson's disease, although it varied a little bit from individual to individual, was fundamentally the same condition. Everyone did roughly the same thing. They followed roughly the same course, and therefore all the treatments could be roughly the same. And that seemed to me to be not the case, just based on my limited clinical experience as it was 25 years ago. That it seemed to be much more heterogeneous, by which I mean there were many different types. So some people sadly did rather badly. They progressed rather quickly. They had lots of falls. They developed major thinking problems. And there were other people who just came in, year out, who didn't really have much to report, got a little bit worse, but it was pretty benign. So it was on that background that we decided we would set up a study, which some of you may have been involved with, which was the Campaign was the original study. Then the follow-up was called Picnics and Icicle. And the idea of these studies was to try and collect everybody with Parkinson's disease in the county of Cambridgeshire. That's what we restricted ourselves to at that point over a 2-year period. And that was done by my very first clinical fellow called Tom Falterney, who's now, some of you may know, as a professor in London, and will come back later in my talk because he's the person who's leading the exenatide diabetes drug trials in Parkinson's disease. So it's quite a small world, I suppose. So Tom set about trying to collect everybody with Parkinson's disease in the county of Cambridgeshire by targeting all the GPs. And then Caroline Williams-Gray, that many of you will know, who runs her own research group up here and her own research in the Brain Repair Centre, then took that project on. And so what we were asking ourselves was, if we just collect everyone with Parkinson's disease, what happens to them over time? Do they all end up essentially looking the same at 5, 10, 15 years down the line? Or are there clearly differences emerging, which is what we would expect? So that was the first question. Are there differences? Then the second question is, well, why? So why are there differences? Why do some people do better than others? What's the basis for that? And thirdly, what does that then mean for therapeutics? So does that actually make any difference when we come to do trials with new drugs or experimental drugs? And so, as probably many of you know, this was actually the very first study done on Parkinson's disease in the community, really ever. Certainly in the post-L-DOPA era. And L-DOPA, the cinnametamappar tablets, came into existence in the late 1960s, early 70s. So amazingly, a very simple study had never been done before. So what did we discover? Well, many of you will know this, but I suppose the sort of headline figures were actually interesting in the sense that the average age that people get Parkinson's disease is 70. That's what we discovered in our first one of these studies, and the second study found exactly the same. Whereas in America, they will tell you that the average age to get Parkinson's disease is 59. And what I always say in America, it's the average age you get Parkinson's disease, you have health insurance and you come into the healthcare system. That's not the same as what it's like in the real world, which is obviously what we have here through our NHS and the GP primary care network. So the average age to get Parkinson's disease is 70. We then looked at the, rather morbidly, literally, at the rate of death in the population over time, because we still follow patients in the original campaign study. And we found that the death rate in the Parkinson's cohort, people who had Parkinson's disease, was exactly the same as if you didn't have Parkinson's disease. So if you take the complete community and you say, if I get Parkinson's disease at 70, what's my chances of being dead at 80? It's exactly the same whether you have Parkinson's disease or you don't. So that's important because it means, well, it's important. It's not the thing I tend to talk a lot about because obviously for research, you need to tell everyone that it's something you need desperately lots of money for. And this doesn't help my argument. But the important thing is most people die with their Parkinson's rather than of it. So that, I think that's an important message because there is a sort of common perception if you've got it, you know, it is going to have some impact on your life expectancy. And obviously, if you get it when you're 25, then it probably will. But if you get it at the average age of 70, it probably isn't based on those figures. It's not to say that it doesn't cause you problems, but in terms of that sort of endpoint. So we average age was 70, doesn't reduce your life expectancy. And then the other thing we wanted to know was how quickly do people run into problems? So one of the things we were very interested in is when do people develop major thinking problems and develop a dementia, which, as you know, sadly is not uncommon in Parkinson's disease, especially as the year goes by. And what we found was that at 10 years, about 40% of people with Parkinson's disease have developed a dementia and 60% have not. So this instantly starts to tell us that people are not following the same course. Because if everyone was doing the same course, you could say, well, actually, everyone 15, 20 years down the line develops a dementia, or nobody develops dementia at 20 years, or occasional patient does, and actually they've unfortunately had Parkinson's disease and Alzheimer's disease. But actually it was clear that there were a group of patients with Parkinson's disease who tended to progress more quickly. They developed an earlier dementia, and they actually tended to also develop these other problems, which are where they develop falls and postural instability. So this we think has been quite influential because one of the things we've been trying to advocate, and one of the talks in WPC I was listening to yesterday, is how we design trials and what are our endpoints of trials. So a lot of people, of course, do trials to try and slow down Parkinson's disease, and the endpoint is there a change in this thing called the UPDRS, the Unified Parkinson's Disease Rating Scale, which is a great measure. But what does it mean? You know, at the end of the trial, you say, well, actually, you're 3 points better than you were at the beginning. You think, well, that's very good for your paper, but actually what difference does that make to me? I don't really know what that means. And most people don't know what that means, and I don't know what it means. Whereas we thought actually what would be a better measure, and I'll come on to this later when we talk about trial design, is actually if we have these very concrete endpoints. So when people hit what they call Hernan-Yahr stage 3, which is where the disease is on both sides and down the middle, so people tend to be unstable and fall, that's a very clear endpoint. You know, sadly, some of you will be aware of the fact there is a point at which you start falling over with your Parkinson's disease. That's very clear point. Similarly, developing, dementia and things of that nature, again, it's a very clear endpoint. So one of the things we've been advocating is it might be better when we're looking at trials to actually have these very clear endpoints not only because they're easy to define, but they make a huge difference to everybody. So if I said, well, actually, I've stopped you falling, or you haven't progressed to start falling as I thought you would, you're going to say, Roger, that's crackerjack, that's terrific. Whereas if I simply say, well, your UPDRS has got better by 5 points, you'll say, well, I'm very happy for you. So it's sort of this idea of milestones, which has come out of this sort of population-based clinical work we've done, is starting to gain traction. So, for example, the FDA, which is the American agency that regulates drugs, is now moving heavily towards a thing called the UPDRS Part 2, which is where they ask the patient questions about their condition. And there's a chap, Thomas Morella, who I spend a lot of time talking to at UCB, one of the big pharma companies, who's working on patient-related outcomes, some of which relate to these sort of clear milestones. So coming back to where I was, the point of our study was to try and work out if people followed different courses, and we ended up saying they did. So the sort of basic facts were that if the older you were when you got Parkinson's disease, you tended to do less well. And there were certain hallmarks at the beginning of the condition which related to not only one's age, but certain memory tests, cognitive tests. So the two tests which we found to be very sensitive were generating lists of animals. I'm not going to tell you how many and what time, because you will then do that for the next minute or 2 minutes, and no one will listen to what I have to say. And then the other was a task where you draw two pentagons and you have to show them overlapping. And if people couldn't do that and were over 72 in our study, they tended to do less well. So that clearly showed that on this study, there was a sort of spectrum of Parkinson's. Younger patients, no thinking problems at all, tended to progress very slowly. Older patients with subtle thinking problems when they first presented tend to do less well. So you sort of think, well, that's a bit of a downer, because if I'm on that second group, now I'm in trouble, and I don't really want you to tell me that. I'll come back to that in a minute. But the value of this coming up with these types of diseases was subtypes of diseases was we can start to explore why that is, and we can also give people better indications of what the future holds. And this work has now been taken on, most notably in the UK, by two studies. There's the PROBAN study, which some of you may be part of, which we're part of here, which is run by Donald Grosset out of Glasgow. And then there's a very big study in Oxford, the Oxford Discovery cohort, both of which have over 1,000 patients recruited to them, which are trying to do similar things. But for us, what we did was, having decided that there were these sort of subtypes of disease, the next question was, can we use that to model where people are going? And that has two implications. One is it's obviously helpful if you come into clinic and I say, well, I can put all this in an equation and I can say, actually, I think this is where you'll be in 3 years, 5 years, 10 years time. I mean, you might not want to know it, and I might not want to tell you, but it at least gives us more confidence in planning, which I think, you know, a lot of people are very grateful to do. The other important point for us was that if we can predict where people are going, then when we do trials, especially with sort of rather aggressive therapies, putting things in people's heads, the Americans are very keen on us doing placebo-controlled trials. So obviously, if I'm putting something in your head, a placebo-controlled trial for a cell or a gene put in your head is to have a hole drilled in your head and someone pretending to do it, which obviously is not something people tend to queue up to have. And if you have to have immunosuppressive therapy, because the cells might be rejected, you might have to take that. So there's all sorts of ramifications of this. Whereas if I can say, well, actually, I know exactly where you're going to go in the next 2 or 3 years based on my modeling, and you don't do that, it's a fair assumption that actually my treatment's made the difference and I don't need to have these sham surgery arms. So this idea of modeling disease, I think, has had major advantages in terms of predicting where people can go now. So it has clinical utility now, but it's also going to help us in the future with some of our trials. The other question that then comes out of that is, that's great, Roger, you told me that people do go in different directions. So why is that? I mean, what's the basis of that? So obviously one of them is age. And then someone will say, well, what is aging? And I'll say, I don't know. I'm the faintest idea, and neither does anybody else. So one of the big problems with all the lab work, and I gave a talk on this 2 weeks ago, for the Cure Parkinson's Trust, was the problem of all laboratory-based studies and how you model Parkinson's disease in the lab, and are lab studies therefore helpful? I mean, I took a very controversial view, as you might expect, but age is something they never do. So all of the studies are normally done in 3-month-old rats. Rats live for 2 years, so that's a young rat. So age is clearly a critical factor. But what we also discovered was that there were certain elements in your genes, genetic variants, which sort of predicted where you would go, which gives us some clues as to what might be going wrong. And then Caroline, who works next door to me, I mentioned earlier, has also been very interested in the role that inflammation plays in all of this. So from our own study, we would say there are certain genetic variants, certain genes you inherit, which may or may not increase your risk of Parkinson's, but they do influence where you go once you've got it. So the way of sort of thinking about this is, if you're collecting rubbish in your house, that's a sort of perfectly normal thing to do. And everyone will do it. If your dustbin has something wrong with it, or you have a small dustbin and you've inherited that because the people before you left you that kitchen bin, you may find that becomes inadequate for your needs. So it's not that you've changed your habit of collecting rubbish, but the thing you've inherited in terms of getting rid of it is inadequate in order to deal with the problem as it comes along. And that's the way we try and sort of think about this, that some of these genes just change things subtly, and in themselves they're not a big problem, but once something else comes along, like Parkinson's disease, it can speed up or slow down the disease. So we've been very interested in this, and this has led to actually us being involved with many global initiatives around genetic studies, where we provide, or you have very kindly provided, DNA from your blood samples. We give it to them, and now there are studies of thousands and thousands of patients to try and identify what genes not only give you Parkinson's, but more importantly determine how quickly it progresses. And so there's a new paper which will come out showing there's a new gene around how nerve cells connect, which seems to be linked in some way to that. Caroline's work here has been very much looking at blood samples as well as fluid off the back, so-called CSF, to see whether your levels of inflammation, also how you respond, if you like, in terms of your immune system, possibly to Parkinson's disease, drive the disease course. And what Caroline would say from her work, which is very exciting, is that if people overreact a bit to the abnormal protein they get in Parkinson's disease, it's alpha-synuclein, that tends to drive things along. So we would say that we've defined these different types of group. That's what we call stratification, subtypes of disease. We think outside of age, there are genetic factors which give us clues as to where the problems might lie, driving the disease process more aggressively in some people versus others, which we can target with drugs. And also Caroline has shown that greater rates of inflammation in people when they first present, as measured in the blood, tends to predict they do less well. So why is all that important for therapeutics, which will be the last thing I'm going to talk about for the next sort of 5 or 10 minutes? Well, to start at the end, if you like, with the inflammation, is that if inflammation is a key driver of Parkinson's disease progression, then one of the things we do have a lot of is we have a lot of drugs that target inflammation. So if you think of all the diseases where inflammation is as a component, inflammatory bowel disease, psoriasis, rheumatoid arthritis, asthma, eczema, all of these have an immune basis. And so the number of drugs that we have available to target the immune system are huge. The question is, do any of those make any difference in Parkinson's disease? What Caroline has shown is that she's shown not only are there these measures of inflammation which tend to be higher in people who are going to progress more quickly, but if you look at the population as a whole and look at people who take immunosuppressive drugs for whatever reason, rheumatoid arthritis, etc., they seem to have a lower incidence of Parkinson's disease versus people who don't take those drugs. In other words, those drugs could be protecting you from getting Parkinson's disease. Now, obviously, there's lots of if and buts in that, because it may be the people who get rheumatoid arthritis don't get Parkinson's disease. And so, of course, the immunosuppressive drug looks as though they're stopping people getting Parkinson's disease, but they weren't going to get it in the first place. But the important point is it raises this possibility that if we target the immune system, we might be able to have an effect on the disease progression. And so that is what Caroline is doing here. She's about to start a trial. She was about to start it last year, and 2 days after she announced she was about to start a trial of an immunosuppressive drug in Parkinson's disease, COVID-19 arrived and closed everything down. And not unsurprisingly, people weren't queuing up to have immunosuppressive drugs when our friend Mr. COVID was wandering around the community, and people didn't think that was a great idea, and neither did the ethics committee and neither did anybody else. But that is just about to start. And that study is really designed to sort of start looking at this idea that if we suppress the immune system with drugs which are already out there, so Caroline wants to use a drug called azathioprine, which has been around forever. If we suppress the immune system, does it actually slow down what happens in Parkinson's? So it makes people progress more slowly. And the people who would obviously be ideal for that are actually the people who normally don't get recruited for trials, the people I've already said who tend to do less well. So the people who progress more quickly. So the obvious study to do, not that we can afford it, so we're having to adapt it, what Caroline is, would be to take people who we think are going to do badly in terms of falling and getting a dementia, treat them and see if we can stop them getting a dementia and falls. We've had to slightly modify it in order to keep it within a cost and a time frame, but the sort of principles are there. We want to try and pick people who we think look as though they're going to progress more quickly. They're going to progress more quickly because we think they have a more active immune system. We make the immune system less active with drugs, ergo their disease does not progress so quickly. So this stratification and the basis for it now feeds directly into clinical trials. There is also another trial which is being done in London by Tony Shapira on a drug called Addenbrooke, which is a cough mixture. And this drug has been shown to affect a particular enzyme called GCase. Now, what on earth is all that about? Well, this enzyme is associated with a gene, and the gene's called GBA. And GBA, Gaucher's, is glucocerebrosidase. This gene, if you inherit 2 of these abnormal genes, you get a funny disease called Gaucher's disease. Very, very rare. If you inherit 1 of those genes, you don't get Gaucher's disease, but it greatly increases your risk of getting Parkinson's disease. And if you have 1 of those genes and you get Parkinson's, you tend to do less well. And that is the single commonest abnormal gene in people with Parkinson's. So in our studies in Cambridge here, in these campaign studies, 5 to 10% of our patients had 1 of these genes. So that is a lot of people have 1 of these genes, and that seems to accelerate the disease course. So what Tony and his team are trying to do in London is select patients who have Parkinson's disease, but not just Parkinson's, have Parkinson's plus 1 of these gene abnormalities, and then treat it with this drug. So this is sort of bringing into play this idea that rather than just recruit everybody to clinic, you select patients for trials. So Caroline's selecting people who have higher inflammation in their periphery, likely to do less well, targeting them with anti-inflammatories. The group in London looking for people with this GBA mutation and Parkinson's, because the drug they're targeting the drug they're using is targeting that gene and what it produces abnormally. So this is starting to move towards more personalized medicine, that we're actually trying to group patients with specific defects to specific treatments. And that's important, because if I do a trial where I'm trying to say, for example, increase the activity or trying to suppress the immune system, let's say, and half of you have a disease where you have a more active immune system and half of you don't, then I've already got a problem, because I'm giving you an immune suppressive drug. Half of you are never really going to respond to it. So suddenly my whole trial is looking rather difficult to interpret, because they'll say, well, only a few of your patients responded, Roger. I mean, overall, it didn't really work, did it? And that would be perfectly true, but half the people don't have the condition or that I'm trying, or the problems that I'm trying to treat. So I suppose the analogy would be, I take 50 breathless people, give them some Ventolin inhalers, and probably 20 of them get better. And 30 of them do not, and you would then say, well, actually Ventolin's a bit useless for people who are breathless. But the reason is that of the 50 people I've seen, only 20 have asthma and 30 have breathlessness for other reasons. So trying to target the treatment to the problem that you think is underlying what's causing the specific problems in Parkinson's is important. On the other extreme, which is where I'm going to sort of finish, is all of these drugs like Addenbrooke, Caroline's trial with azathioprine is trying to slow down the disease. Our big push, if you like, has been on the other side to say, we're going to take the people who actually look as though they're doing quite well with Parkinson's disease. So these tend to be the slightly younger people who tend to do very well with their drug therapies. The problem with the drug therapies, as you know, the Madapar and Sinemet, is over time, and the dopamine agonists like rotigotine and ropinirole, is they can cause behavioral problems. So people can start doing slightly odd things. And that's because the drug's stimulating bits of the brain it shouldn't be doing, because they're intact, but you're just taking a drug that stimulates everything. And the other problem is, if you take Madapar and Sinemet over the years, as you will know, the responses become a bit unpredictable. People don't always respond. Sometimes they respond too much. They develop involuntary movements. So our strategy has been to say, well, can we deliver dopamine better to the brain? It's not a cure, because we're not getting rid of the disease, but actually the idea is to just say, don't bother with your tablets. We've sorted that out. We've essentially put your tablets directly in your head. And so we have tried to do that in 2 ways. One is putting in dopamine cells. and the other is to try and inject a gene which codes for the enzymes which make dopamine normally. And so we've done this in a number of ways. So in the gene therapy, we did a trial called ProSavin, which had 3 patients. We injected a gene into the brain. This was with a company called Oxford Biomedica 10 years ago. We injected it, the gene infected the cells where dopamine is normally produced, and those cells then became little dopamine factories. And it sort of worked, but it didn't work fantastically well. And the reason it probably didn't work fantastically well was it was not enough hooch. We didn't give a big enough dose. We being me, but I was told to give that much by the company because that's what they thought. So that was a bit disappointing, but it showed it was safe, and it showed it sort of it helped, but we probably got the dose wrong. So it's a bit like giving, you know, if you've got a chest infection, just giving you a small dose of penicillin. It sort of helps, but it isn't helping a huge amount. So they came back with a new gene therapy, which is ProSavin 2, which was made by Oxford Biomedica, who were then bought up by Axovant for 460 million, who've now become Cyogene. And that trial, we've done 4 patients here, and we're going to start again in the beginning of next year with a bigger, better gene therapy. And the first patient who was treated, who I talked to the other week, definitely feels his disease has stabilized with this gene therapy. So I'm optimistic that that will work to stabilize people, may even improve them. On the cell front, as many of you will know, we've been trying this for years, and we did a study called Transeuro, which is where we put fetal dopamine cells into the brains of people with Parkinson's, which proved to be a complete nightmare in terms of getting sufficient tissue, getting enough tissue. And that trial is now finished, and we're about to start looking at the data for that. But I think the real excitement from my side on that is that there are now these stem cells which you can turn into dopamine cells. And this has really caught fire. So in the world now, there are probably well over $1 billion, $2 billion invested in this field. In Europe, I work very closely with the group in Sweden, where we now have a stem cell derived dopamine cell. It's in the freezer in the Royal Free. It's been tested and shown to be safe. It's been tested in Sweden and shown to be effective in animals. We're now moving towards a clinical trial. There are issues about how we deliver it, but we're hopeful that that trial will start next year in a few patients with Parkinson's disease. This trial, actually, we have a grant from Novo Nordisk, who are a big pharma company, the 4th biggest pharma company on the planet, and they have now developed their own cell therapy Parkinson's, which they now wish to bring to a trial in Cambridge, probably end of next year, the year after. And this is being replicated around the world. So there are 2 companies, 3 companies in America who are doing it. There's a big group in Japan are doing it. So the idea of simply replacing your lost dopamine cells by dopamine cells we've made in the laboratory is becoming a reality. And one of the reasons why people are very excited about it is, apart from intuitively it makes sense, it could be quite cheap to do it. So if I start with a small well of stem cells, within 3 weeks, I can make enough dopamine cells to treat the entire, well, if I start off, let's say if I start off with 1,000 plates, I would have enough dopamine cells in 3 weeks to treat the entire population of Europe with Parkinson's disease. So it's only a 3-week manufacturing run, which in the world of pharma is very cheap. So to sort of conclude, we started 20 years ago trying to work out why there were different. Did people with Parkinson's follow different courses? The answer is yes. There are some people who have a relatively benign course, which seems to be mainly around problems with the dopamine system. They are the very patients we're now targeting with our dopamine cell and gene therapies, and they are coming to clinic, and cell therapy has caught fire in the last few years. And we're very fortunate here that we're seen to be very active in that area and directing that field. On the other hand, we also, through this study where we collected people, found that some people sadly did not do well. That has enabled us to try and understand why that is. We've identified factors, both genetic and inflammatory, which seem to be driving that process. And that has now opened up new therapeutic approaches, especially around drug repurposing, where you take a drug that's already out there, like azathioprine, for inflammation and use it in Parkinson's, or ambroxol for coughs and you use that in Parkinson's. And the beauty of drug repurposing is you know what the side effect profile is. It's normally dirt cheap, which means pharma aren't interested, but we are. And so it's quite easy to roll it out. And if you think you've done well with it, the other beauty of it is you can carry on taking it afterwards. Whereas if it's a specially made drug, especially for a trial, as people who will remember the story with GDNF, the growth factor, once the company has pulled out, you can't get your drug. So it's exciting times, lots of things happening, and I'm very happy to take any questions on any aspect of that or anything else, really, to be quite honest, as long as it's related to Parkinson's.
Roger, as always, you're an inspiration. I think I feel terrific having spoken to you, and I'm certain everybody around the screen feels the same way as I do. There's a couple of questions that come up on the chat line. If I could tackle the first one, which was, does the work on medication suggest that discussions in clinic should take a holistic view of patient's condition to include other health issues and medications, not just Parkinson's specific?
Most definitely. So this is a very tricky area, actually, because I always feel a bit rubbish, really, when I'm in clinic, because the trouble is we have no time to see people. So, you know, like my Friday clinics are normally 15 minutes per patient. And, you know, it's very difficult for us to really get to the core of the problems and all of the problems. And so we often just are a bit superficial and go for what we think are the major problems. And that's a reasonable place to start. But other conditions are very important. So the number of patients, for example, I see who have low blood pressure and feel a bit dizzy and lightheaded, which is a natural feature of Parkinson's because it does affect that part of the nervous system which controls blood pressure, and the dopamine drugs can drop it, who are still on tablets for blood pressure, I find quite extraordinary. So, you know, you're saying, you know, you'll get letters saying their blood pressure is low, what should we do? And you think, well, perhaps you could stop the tablet that's dropping their blood pressure, and that might be a useful starting point. So often we don't always factor everything in. So I agree, a much more holistic approach is important. And there's also a tendency for people to assume everything is Parkinson's disease. And I've got a tingly hand, a bit weak in the hand, well, that's your Parkinson's. You think, no, it's not, you've got carpal tunnel syndrome. I mean, Parkinson's may be contributing, but it ain't the cause of it. I've got a painful back. I mean, Parkinson's may be contributing, but that's not actually Parkinson's disease. So I do think it's important that we try and see the patient as a whole, and also, which is what I like about these patient-related outcomes, what actually matters to them. So I think in medicine, we sort of say, oh, I can see you've got a problem here, I'm going to treat it. And I'll say, yeah, but I'm not bothered about that. I'm bothered about this. You say, yeah, I can't do anything about that, but I can do something about that. So take this tablet because it makes me feel better that I'm doing something for something I can do. So I do think we need to be a bit more holistic about taking everything into account around Parkinson's and other conditions.
Do you see wearable technology that's feeding information to you having a future?
So what do I think about wearable technology? That's a very good question, Keith. I think it has great potential. I think there are two things that I would say about it. So I think what I love about it is it's objective, and you can collect data over long periods of time, and therefore you get a much better feeling for where people are. The two problems I have with it is I don't always know what it means. So I don't quite know what the data actually means. And then I'm also slightly worried that people can become a bit obsessed by it. So going back to my previous one, I remember one patient in the past who became obsessed with doing their blood pressure. So they would be telling me their blood pressure all the time, every day. They were doing it 8 times a day. I mean, I didn't want to be unkind, but I wasn't that interested in their blood pressure because they had no symptoms with it. So it was very nice that they could plot it all out. But what was the value of it?
What was he doing?
So I think it's understanding what that wearable technology tells you, and then what that actually means therapeutically, and people not getting obsessed about it, you know, so everything revolves around their technologies rather than living. Yeah.
Thank you. Mina has asked a question about her husband, Madden, who's got real problems with contracture on the knees, and just wondered if there was any ideas that you might be able to suggest. I know we shouldn't be looking at personal issues, but maybe a general question on contractures.
Yeah, so I think one of the first question you have to ask yourself is whether someone truly has a contracture or just they have this thing called dystonia, which is where you have abnormal tone in muscles, so they end up in a slightly abnormal posture. So people can end up, for example, classic one in Parkinson's is the foot turning in, painful dystonia in the morning. And the distinction between dystonia and a contracture is that a dystonia is muscle contractions which can be released. Contracture is that everything has got fixed. So if someone has contractures, then the only way you'll get rid of contractures is with physiotherapies and actually possibly surgery to release the tendons. Because once it's fixed, it's fixed. So that has to be unfixed. Whereas dystonia, you can obviously treat with medication or Botox to actually release it. So the important thing is if someone has an abnormal fixed limb, arm, leg, whatever, try and work out whether it's dystonic or not. And if it's dystonic, when they go to sleep, it will disappear. If it's a contracture, it's there regardless.
That's fascinating. My wife has got that problem with her arm, and you've just helped me enormously. So thank you very much indeed. Jackie's asked a couple of questions. How does rivastigmine help people with PD?
Yeah.
And also, Sylvia's just been taken off her blood pressure medication after a number of falls, which touches on what you were just talking about.
Yeah. And the rivastigmine will relate to that as well. So rivastigmine is a very interesting drug. So rivastigmine doesn't work on the dopamine system. It works on a system called the cholinergic system, acetylcholine. And rivastigmine was developed for Alzheimer's disease. So in Alzheimer's disease, you get all this pathology with all this amyloid and such like, but you lose this thing called acetylcholine to the brain, probably secondary to the pathology. So they tried to give drugs which boosted it. And my experience in Alzheimer's disease doesn't really work very well unless you're very early stage. It then became quite a useful drug in Parkinson's, and it's used it was initially used for people who started to develop hallucinations or seeing things or misrepresenting things, because the loss of acetylcholine in the brain in Parkinson's is greater than in Alzheimer's disease. So I found it to be very helpful if people start seeing things or misseeing things and start acting and behaving around that. Rivastigmine can often help very well. There's also this story that same chemical, the acetylcholine, is also deficient at the bottom of the brain, in the stem of the brain, and drives some of the walking problems, the freezing of gait, and the sort of shuffly type problems you can see. So people have used rivastigmine not only to help some of the cognitive, psychiatric aspects of Parkinson's, but to improve people's walking. Now, whether it really does or not, I don't know. Some people say it does help their walking because it makes them more attentive, so they can actually concentrate more on it. But there is definitely trial data to say that it can help people with their walking. So anyone who has a problem with freezing, getting stuck and slightly stuttering, possibly falling, I always tend to give them a trial of rivastigmine. And I also use rivastigmine in people who are starting to see things.
Thank you very much. And David, our illustrious editor, asks, he knows that you're worried about Brexit affecting research. How has that transpired over the first few months of Brexit?
So far, it hasn't been as bad as I thought. And I think the reason it hasn't been as bad as we thought is that we've actually still signed up to the European Research Council. So the big worry was we would pull out of the ERC, and all the funding which comes with that would therefore have been lost. And that would then not enable us to interact with other groups around Europe to solve these bigger problems. It's fair to say it has had some impact. So there is one grant I am on, a European grant, which we've applied for funding, except I'm not allowed to apply for funding. Everybody else is. I just have to smile and be a good citizen because we're not signed up to this particular European grant system, which we used to be. How much Brexit is impacting that, I don't know. I mean, it's not without its problems, Brexit. So one of the issues we're discussing at the moment is for our stem cell trial, the cells are sitting in London, and the idea is to transplant some patients in Cambridge and Lund in Sweden. And we're not entirely sure how we get the cells from London to Sweden and whether we have to send them via Ireland, which didn't exist before. So that's these are the sort of things we have to deal with.
Can I take you off spotlight? Because I think, let me take you off spotlight. If I put you back on gallery view, Barry, you wanted to ask a question. Can I ask you to unmute and ask your question?
Yeah, I'm unmuted. Can you hear me?
We can.
Yeah, my question is, does simply physical space or the presence of senescent cells in the brain constrain the growth and integration of any implanted healthy stem cells?
I didn't quite catch it. It was something about whether there's enough space to put cells in. Was that the general gist?
Yes, my question is basically, if you're going to transplant stem cells or iPSCs into the brain as a replacement for senescent or faulty cells in the brain, is there a physical space problem?
It's a good question. There isn't, is the honest answer. And the reason is that, so where do I start with this? So in Parkinson's disease, you have about 500,000 cells on either side of the bottom of the brain, and the top of this thing called the brain stem. So here we go. So here is a brain. To the patient
thank you.
A few years ago.
Cheers,
So at the top of this here is where the dopamine cells go, and they project deep into this bit of the brain. So this is the thing called the nigra, and that's the striatum. So they have to project over quite a long area, and you have 500,000 either side. When you've lost half of those, 250,000, you get Parkinson's. What we do is we don't put the cells back there. We stick the dopamine cells where the dopamine normally works, which is deep within the brain. So it's in a thing called the striatum. And that is a pretty big structure. So it's sort of,
Fine. Okay.
it's sort of, so this is the front of the brain. So we sort of aim for this sort of area here. So it's a much bigger area. And ultimately, we only transplant in probably 2 to 4 million cells, which sounds like quite a lot. And about 10% of them turn into dopamine cells. But you have, I don't know how many, 100 billion cells or something in your brain. So actually, there is sufficient space for the cells to survive and integrate within the brain. But it is a good question about, axal space. And then some people have said, yeah, but Roger, if I have a transplant, can I have a top up? And then the question is, if you're transplanting into a transplant, you might be killing some of the cells to put the new transplant. So I don't think that will happen. But I think for these type of work, there is sufficient room.
Thank you. You were talking that Caroline was wanting volunteers. Is that, what's the availability of that? Is that going through the Parkinson's UK hub for?
I don't know is the honest answer, Keith, because it was obviously set up quite some time ago.
Yeah, right.
And then it's been delayed for a year. I think there's Molly who works here, and obviously Caroline, myself, and Marta. Anybody's interested in trials can always write to us or email us, and we can see whether you might be suitable or not.
I'll drop a note to Marta and get some feedback so I can let the group know.
Yeah.
Roger, has anybody else got a question to ask before we let Roger go and pack up his car for his camping weekend?
One
I've got to talk to China this afternoon. That's a bizarre thing you have at the moment.
Can I ask one?
Can I?
Irene, go first.
I just wanted to ask about exercise. Sort of, we're always told to do as much exercise as possible, but it seems that it's also the type of exercise that makes a difference. And maybe young people are doing better because they can do more exercise. What do you think about exercise and the different kinds and, supplying it? I think PD sufferers would really welcome a more structured approach to recommending exercise.
Yeah, it's a good question, Irene, and I'm probably not the best person to answer, because the first thing I would say is that exercise is a very good thing. So, full stop. Clearly it's now been shown that exercise earlier in life is preventative from problems later in life. So exercise does things for your brain which we still don't understand. It's also fair to say that exercise, at least experimentally, increases growth factors, fertilizers in the brain to make cells happier, especially a thing called BDNF. So there's no doubt that exercise is good for you physically, and it's good for your brain health. When it comes to Parkinson's disease, obviously doing exercise is good because it keeps everything as fit as it possibly can be. Now, what is the best type of exercise? I don't know the answer to that question. There are things like PD Warrior where people, there are web-based and whole programs that people have advocated. So I don't know what the best one is, and I don't think anyone's ever proven one therapy against another. The difficulty has always been trying to do trials of physical exercise in Parkinson's, because the people who volunteer for your study are people who want to do physical exercise. And so your control arm, who aren't supposed to do as much physical exercise, will probably do as much as the active arm, so you can't tell the difference. So it's a bit of a problem trying to do the trials. But there's no doubt that in those studies, so there have been published trials of Tai Chi, which is not really that physically active. That's been shown to be beneficial. There are other small studies where physiotherapy and exercise programs have helped people. Whether it just helps them because they're fitter, So, you know, if I stumble a bit, I'm actually stronger and quicker and I can deal with it, or whether actually it's done something fundamentally to slow the disease down in the brain, I don't know. But my own advice is it's very important for people to do exercise. I think one of the difficulties is if you look at these programs and think, wait a minute, I can't do any of that. That's a bit over the top. You sort of slightly give up and feel a bit intimidated by it. Or you have a go at it, get yourself exhausted, and then you're 10 times worse, because obviously if you get very tired, as you'll know better than me, you know, things get worse. So it's trying to balance the exercise. So I think this personalized medicine also fundamentally should become personalized exercise. I think you look at someone, and coming back to a previous question about comorbidity, if you've got an arthritic hip, you know, suggesting you run a half marathon isn't going to be your answer. What can I do in a swimming pool that would be better for my Parkinson's disease and my hip? So I'm a great fan of it, but exactly what treatment, I couldn't tell you the answer to that, I'm afraid.
Thank you.
Irene, a couple of things I just add there. One, I'm doing some work with inside Parkinson's on developing exercise programs across Bedford, Cambridgeshire and Peterborough. Early stages, but we'll be communicating that probably the early part of next year. And the other thing I just wondered was, Ruth, if you wanted just to have a word about Hannah and Anita's exercise programs.
Yes, hi Keith and everybody. If we have an exercise class and you've got a qualified Parkinson's instructor, they are absolutely fantastic, and they will always give you different versions of what you can do to adapt to your capabilities. So whether it be seated, standing, don't be put off by going to any class, because most instructors will be able to adapt it, say, to your capabilities. But certainly I can tell you from the classes we've been running for many years, a lot of our members have seen the benefits, certainly with balance, coordination, and we're very much looking forward to our ping pong later. We're hoping to join coordination and balance as well. So I would say a real big thumbs up for exercise, and I really have seen the benefits. Thank you.
Thanks, Ruth. One final question, maybe, from Jackie, who's talking about Sylvia, who spends a lot of time asleep and wonders if that's a late stage of Parkinson, or is that just an old age thing?
I'd say it's a bit of everything. I mean, you know, all of us will know that, you know, as you get older, it seems a bit easier just to doze off in the chair, and that's very common. And it's not just humans, you know, if you've ever had a pet, an elderly pet, the dog will sleep forever and the cat will sleep forever. So as you age, you do tend to spend more time asleep. Sleep and Parkinson's is rather complicated. I mean, people can suddenly fall asleep with Parkinson's for no reason. It can be brought on by the drugs. So there was a big hoo-ha about this 20 odd years ago with the dopamine agonists, Rapinarole and such like, with sleep attacks. So I think you know, and your normal sleep is often a bit abnormal in Parkinson's, because probably the centers that control sleep are a bit affected, and partly because you're a bit immobile at night, so you can't sleep as deeply and as well as before. And that obviously has a knock-on effect. If you don't sleep so well at night, you're going to sleep more during the day. So I think it's a bit of everything, really. I personally think a bit of a power nap after lunch, which a lot of people sort of rather apologise for in clinics, saying, "Oh, you fall asleep for an hour after." I think terrific, bring it on, because you know it's much better than taking an extra tablet if you have a bit of a kip and then you're off again. And some people with Parkinson's get this extraordinary thing of sleep benefit. So there may be people here who their best time of day is first thing in the morning after a good night's sleep, and then they say, "Roger, it gets worse once I take your tablets." In point of fact, they were going to get worse anyway, because they just, sleep benefit restores dopamine for a period in the morning. Most people are the opposite. That's normally their worst time of day is first thing in the morning, because it's the longest time between their tablets. So sleep in Parkinson's is a bit complicated. I would say it's probably a bit of the Parkinson's, it's probably a bit of being 90, and those would be my sort of thoughts.
I'm overwhelmed by the session today. I don't know whether Ruth and Mark want to just say a thank you to you.
Yes, certainly.
Thanks, Ruth.
Certainly from Peterborough. I mean, I've actually seen Roger talk at a couple of places, and I was very keen for as many people to join us as possible. But like Keith, I'm very inspired by what you say, and certainly there's some real big factors today you've mentioned that affect me personally. So I hope the rest of the Peterborough group have enjoyed it as much as I have, and very much appreciate you coming on today. Thank you, Roger.
Thank you. I hope your budgie enjoyed it as well, if it's a budgie.
Mark, how about you?
Oh, yeah, thank you. Sorry, I joined the session slightly late. I thought it started at 11, but yeah, very informative. Obviously, I don't know if Keith's introduced me, but I'm a nurse working at Cambridge Manor, and I've looked after several residents living with Parkinson's and dementia, and we've seen the trajectory, and we've seen that how we support not only the resident, but the relatives importantly as well. But some very useful points, certainly on river stigma as well. It's a drug I'm familiar with, but you've just made a few more things clear there. Thank you very much.
Thanks, Mark. I think all I can say, sorry, Irene, go.
No, regarding the stem cell therapy, would it have to be done repeatedly, and is it likely to be expensive?
Two very good questions. The first would be no. The hope would be it would be a one-off treatment. As to the expense, you know, what I was sort of trying to imply at the end was because it's quite quick to make the cells, in theory it shouldn't be very expensive. But it's not for me to eventually decide the price of these things. So the companies will decide on the price. And of course, you know, the excitement from our point of view is if I took you, Irene, and gave you back 250,000 of your dopamine cells, I wouldn't get rid of the disease because you'd still have the disease, but I have repaired a critical part of it. You wouldn't need to take any drugs because all the drugs work on that system. So you could see if it worked, you just have a one-off treatment and that's it for that part of the Parkinson's. And obviously then if it's a one-off treatment, the company will want their money back on that. So it might be more expensive than it actually is needed, but the reason I think people have got excited about it is affordable, I think. Whereas some of the cells people are thinking about to repair the brain, it takes you a year or half a year to make them. And the cost of doing that in a sort of clinical grade factory is colossal.
Are we likely to see it in our lifetime?
I would hope so. I mean, the great excitement for me in this, outside of things I've said, is that this big pharma company want to take it on. So you know, Novo Nordisk, you know, they make all the insulins in the world, more or less. So if they decide this is a runner, which is what they think it is at the moment, they will put an enormous amount of money into this. And the thing about companies is they're very impatient, which is their problem, but it's also their advantage.
Yeah.
So they will push this forward. So my hope is that I will have to retire in 7.5 years' time, that it will be a therapy that will be either in the final stages of trials or will be becoming available.
Awesome.
Oh, sign up as soon as possible.
Can I, on behalf of everybody around the screen, Roger, say thank you so much for your time. I'm very grateful. I know you're a busy guy. Enjoy your conversation with China later. And I won't ask to mute, but I think a round of applause. Thank you so much.
Holiday.
Yeah. Thank you very much. And yeah, it's a great pleasure always to talk to you. You're the most enthusiastic, interactive people I talk with. And busyness should never prevent me from talking to you. I'm very happy to do it anytime.
You're awesome. Thank you so much. Best wishes. Have a good time. Thanks, Roger.
Take care. Bye-bye.
Cheers now. Bye.
Mind on your camping.
Thank you very much.
Bye now. Well, everybody, we had a record number of attendees today. It peaked at 60, I think, which is just fabulous. So I just want to say a huge thank you to everybody that's joined us, our new visitors, our friends from Peterborough, friends from Uttlesford. Thank you so much. We'll see you in a couple of weeks' time. Thank you very much indeed.
Thank you.
See you all. Thanks a lot now. Bye.
Bye.
Bye.